Hi, I'm Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is waveforms. I want to draw the waveform on the screen. I just realized that I forgot to update my OBS scene, so let me move myself around. That's better. And when I say that I want to draw waveforms on the screen, I mean the kind of waveforms that you see when you are recording something. And we have something similar to that in our library already. It is over here at RMS. No, maybe in the circular buffer. I forget. We had something like that. Where is it? Come on. We go to the demonstration effect and we have some line draw that, and it is in the circular buffer, so it really is on this page. We don't get to see anything right now, probably because there is no audio coming through. Okay, so there should be some, oh, there are some waveforms, but they are white, and then it's a white on white kind of thing. So let me check that real quick. Here we don't really receive any notion of color, so we are just drawing in the current color. So I suppose what I have to do to make this show up is put a color in there. But I forget how to use colors. So let's go there real quick. Okay, looks like this. So we change from this color to some dark color, and then we'll see some waveforms. Naturally, I have to reload the plugin. Okay, still in white. Now I don't know why. Oh, because this is not a color. This is a color. Turn time is a charm. Here we go. This is a good old waveform. But the way that we are drawing this waveform is super silly. Let me switch the kind of noise so it's not just a wall. This is kind of nice, isn't it? How we can see the different kinds of noises. Cool stuff. So this is the kind of component that I think is super helpful to tune when you are using an audio effect. If you can see what it's doing to the waveform, I think that is usually beneficial. But the way that we are drawing this waveform is super silly. We are storing each and every sample, and then we are drawing lines between the samples. Now, of course, this kind of works, and if you're doing something like an oscilloscope, that's, I think, the only way to do it. You have to store all the samples, right? Because you want to be able to eventually zoom into the waveform and see each sample individually. And that's how this all started, actually. The first incarnation of this component was way back, like 1 year ago, when I was doing an oscilloscope. But we need to do better. We don't need to store as many samples, and we don't need to draw as many lines. And this is going to save us some memory and some CPU. Win-win situation. And we can store a lot less information. Right now we are storing 48,000 samples per second. So if you have, like what we have here is probably 2 seconds, and 2 seconds worth of samples is 96,000 samples. And we don't have 96,000 pixels on the screen. In fact, we only have about, what, 3,000 on a 4K monitor. If you go up to 5K, I think it's like 4,000, something like that. We don't need to store 96,000 samples to display on a monitor that is only 5,000 pixels wide. So what we can do is just store the range of the maximum and the minimal sample in that area, and we can display this in a smart way by just drawing what really is going to make a difference, instead of the way that we are doing now, where we are essentially repainting the same pixel over and over and over again. And so that's the component that I'm planning to write today, which is this component that is going to store samples, but not all of them. So it's just going to store the minimum and maximum, the amount of information necessary to actually draw the thing. And then we are going to draw using fewer lines. That's the concept anyway. So to get started, I think we need a data structure to remember. I was gonna say samples, but maybe not samples. Maybe some other name would be more appropriate. I don't know. So let's go to the place where we have some graphical functions. We do have a couple of them here, so maybe this is a good place. Waveforms. Is waveform a single word or two words? Waveform is the name of a DAW. Okay, it's a single word. And it's trying to find some name for the x-axis, which is not necessarily a sample. It is a bunch of samples. Okay, I'll just call it waveforms. And I don't have a word for this concept that I have in mind, or not yet anyway. So we will need data structures, maybe just one data structure, but we will need a data structure. So let's have a function waveform init that is going to be called down here when we initialize all our stuff, and that's where we are going to create this data structure. What is in this function here? Okay. We are after all that, so yeah, I think that's the place to put this. And then let's go ahead and define a data structure. Come on. There you go. And the field that I need, well, I think I need a couple fields. I think I need this notion of how many samples to store. So I guess this samples is going to be this sample is going to be the list of samples that I store to actually display, but it's not really a sample. It is more like the height of the waveform at that position. Yeah, that's what it is. It's not even a height, it's a low and a high position. I I'm tempted to give this a different name, but I don't know what name to give it. I'm gonna call this lines, points, times, forms, frames. What is a good name for this? For a vertical slice of a waveform. Vertical slice of waveform. Yeah, that's not gonna give me anything. I think I'm gonna call these slices then. There you go. And I don't think I need to store the size separately because I have an array data structure that stores the size. So is there anything else that I need? Well, I need to define what is a slice. So let's have a data structure for that. And I'll have a low and a high. And then the intention is that I'm going to draw a little rectangle between the low and the high. Yeah, okay. Let's review this. I have a data structure which is a bunch of slices, and each slices is essentially just an array of slices, and each slice is a data structure that has a low and a high. Okay, then let's create a waveform new function, and for this I do need a size. Is it size? Do I call it size when I'm creating arrays? Yes, I call it size. I really want to find that function that, okay, here it is. Yeah, it is size, great. I'll have something like this, except that everywhere where there is array, we'll have a waveform instead. And then this is the only field in that data structure. So we put it there, and then we create an array of that size, and then we need to iterate over the array. I am defining this local variable called waveform slices just so I don't have to go to the data structure every time. Not that it matters that much because initialization of data structures is only going to happen once. But here we are. And then I start this index at -1. And I increment 1 every time, and I want to run this loop for size number of times. Again, creating local variables just to organize things and save some memory accesses. Though I haven't really measured, so I don't know if this saves memory access and that's a good thing, or if it is creating more local variables and that's a bad thing. But my intuition tells me that memory access is expensive, so doing this is advantageous. I will be right back. Okay, so let's destruct this array and get its fields. And then I finally have this that I can use there. Then what I want to do is get into the data of that array in this position. And in there, I am going to allocate a data structure for a slice. Trying my best not to sneeze on your ears. Right, so this is going to allocate one slice per element in the array. Great, I think that in terms of data structure, that is all we are going to need. Right, so let's create... Oh, there is actually more that we need. Yeah, let's think about how this is going to work. I need to know, you're going to start giving me samples, right? You're going to allocate this data structure and you're going to start giving me samples, but I don't want to store every sample. I only want to store the slices, and then like 1,000 samples is going to be compressed into a single slice. I'm just going to get the low and the high, or the minimum and the maximum for that slice. And then I'm going to draw a little rectangle. So each slice is eventually going to be 1 pixel on the graph. And in order to be able to compress, to know how many samples to compress into a single slice, I need to know the length that you want to store in this waveform. Yeah. So let's add a new field here. So besides the number of slices, I also need the length of this waveform in milliseconds or in samples. Right, and then when defining this, or when allocating this, you need to provide me that information. And the beautiful thing about doing it this way, I realize that the names are not great. Size and length are pretty much the same thing in some languages. But the beauty of doing it this way is that if you wanted, you could have a waveform of an hour. And we are only going to really store the number of slices. So even making bigger monitors will be more expensive because you need to store more to be able to display. But if you want to make the waveform longer, that's relatively cheap. Now, of course, I am not thinking about cases where you would want to zoom into the waveform, because to do that, I would need to store more slices. And maybe that's something that we can look into the future, but right now, I don't think that's super advantageous for the kinds of effects that I have in mind right now. I know that there are effects in which this could come in handy, but for now, I will not give you the possibility of zooming in, though it wouldn't be the end of the world. I would just need to store more slices. And in the worst case, if you want to show each sample, I would need to store each sample. So there would be a one-to-one correspondence between slices and samples. So let's give these guys a better name. Instead of length, how about duration? Because that has a relationship with time. And size, I could rename to slices, size, yeah, that's not too bad. And then it does become kind of silly for me to do this because I'm sort of like storing that information and right on the next line retrieving it, but I'm okay with that. Now, from the developer's perspective, using this library, when they see something like this, I think it is going to be relatively straightforward what I mean. Yeah, I think that these names are better. So let's write a function that I'm going to call it push. Is this how I call other things? Yes. So it's similar to pushing into a circular buffer. We will need a waveform and we'll need a sample. Yeah, this is actually a circular buffer, isn't it? The waveform is a circular buffer. Let's revisit this decision. And each element in the circular buffer is not a sample. In the circular buffer that we have implemented, you can only push samples into the circular buffer. You don't have essentially polymorphism into this data structure. But that's exactly what we need right now. We need to have, this data structure, the waveform data structure that we are pushing into, is a circular buffer of this slices data structure. This is going to be more interesting and intricate than I was expecting. I wonder if we could change the circular buffer implementation to add some sort of feature in there that allows me to use just the pointer in the circular buffer to my advantage, but not necessarily store samples in there. So, this is going to be interesting. It all started with this notion of I want to be able to draw some waveform. To do that, I don't want to do it the silly way, storing everything. I just want to store slices. But slices are these data structures. And I know that I could, instead of using a data structure here, I could just store a number and then I would assign different meanings in the circular buffer, like odd positions are lows and high are in even positions. We could do that. It's not the end of the world to do that. But I think that we are starting to pull things out of the hat and it's going to be more and more intricate and complicated. We could have a circular buffer that is kind of polymorphic in the sense that it's going to return pointers to me. And then I can use that in my waveform. Yeah, I think that's the way to go, actually. I wonder if I should just stop this waveform endeavor and look into making a polymorphic circular buffer. Yeah, let's comment all of this out. Let's go into the circular buffer and see what we can do there. In particular, let's look at this push function and the get function. The push function is interesting because it advances the index. And the get function is interesting because it uses the index. So maybe what I want is to extract the push and get so that you're not necessarily getting a sample and you're not necessarily indexing. You're not necessarily pushing a sample. You can be just advancing the index independent of pushing the sample. And instead of indexing into the data directly, I could just get the index. And that way I can store samples in there, of course, naturally, that would be the straightforward thing to do, but I can use the addresses as pointers to do polymorphism. crazy stuff. And Bo is here. Hey Bo, how are you doing? We started with something simple today and it got complicated and weird. Oh, I'm sorry to hear that. I'm not feeling great myself, actually. I am constantly going to that screen and trying to get a hold of myself. Yeah. Right. Okay. So we started with I want to be able to draw waveforms, and now we are talking about polymorphism in containers and generics, I suppose. Yeah, it's gonna get weird. Okay, so let's break apart this push function into two functions. One that is going to be called I'm gonna say index advance next move forward, and I need the circular buffer. And the cool thing is that I advance the pointer first and then I store the sample. So I believe I can copy and paste a bunch of things and it's mostly gonna work. Yeah, let's see. I had another brainwave when I saw the title for the stream. What does that mean? Right, so this advance function, its purpose is just to update the index in the circular buffer. And it could be nice if it returned the advanced index. So let's see. First of all, let's see if we are using these variables. And we are. And over here we are not. Right, okay. I'm liking the way this is shaping up. Bo says, you know how some vector-based drawing software can trace lines and convert them to Bezier curves? You probably mean trace lines and convert them to Bezier curves? Yes, I am aware of that. I think that it is one of those, I think Inkscape has that, where you have a line drawing and it takes that line drawing and tries to find a path. What if you could trace audio waveforms into playable waveforms? Oh yeah, I remember watching videos of people doing that. Someone has tried that on YouTube already. They had like just the drawing of waveform and they found, of course, it wouldn't be super high resolution, but you can recreate the audio based on the drawing. Not at all what I am planning. What was the title of this stream? Drawing waveforms. Yeah, the idea was just to be able to draw waveforms like this. In fact, we are already able to do this. It's just that I'm storing every sample and I'm drawing every line for every sample, which is silly. I don't have that many pixels on the screen. And then process those Bezier curves, see what it does to the audio. Yeah, that is an interesting idea. I'm not gonna really try the Inkscape thing right now. Just know that it exists. I don't know how well it works. Okay. So let's review this. I really like the way that this shapes up. Now let's review this. Okay, so the index and the signal are just parts of the circular buffer that I extract, and I think I prefer to call these things circular buffer dot. And I know that the name is longer and it is kind of silly because they are like local variables, but I'm just following this convention that it kind of behaves like an object, kind of looks like an object, if I do it that way. And of course I need to update all the uses. Okay, I think I got it. So these are longer names, but now it looks like I'm just index after I do this ceremony in the beginning. The rest of the code looks like I'm just using fields from that object. Looks more object-oriented that way. Right, so let's review this. Get a hold of the index, get a hold of the signal, get a hold of the signal's size and data. Then I update the index, then I check the index against the size. If it is over, then I wrap it back. Then I store this new index and return it. And over here, I just use that just like that. Okay. Now let's do this. I can just store stuff in there if I want. Oh no, but there is the offset logic. Yeah, right. And again, I guess I'm gonna call it .index.get. And this is just going to be me getting the right index, doing this whole offset logic. Okay. Again, I think what I need mostly is just to move things around. Oh, this signal data needs to be below. Let's review and rename a bunch of things. And then the signal, the only reason why I need the signal in this context is to get its size. So I'm going to just go straight ahead and say circular buffer signal size. Right, Bo says. Sweet, I need to Google that. Thanks for the tip. Yeah, if you want to, okay, so let's take this tangent real quick. So if you are interested in, given the JPEG, an image of a waveform, if you are interested in trying to get a hold of the audio, first of all, if it looks like a block of If it looks like this, then you have very little chance of getting anything useful out of this. If it looks more like this, you have a fair chance, not a high chance. And if it looks like this, then you have a really high chance of reconstructing this very accurately because you have enough information in here. There's enough data. It's not just a blob of black. And the way you do this is, let's take a screenshot of this so it stops moving on the screen. So one way to do it, a simple way to do it, at least it may give you bad results, but it could be a good start. So the way you do this is, you see how, for instance, here, there is like this blob of several pixels. In this part, there is only one pixel, so that's good. But over here, there are several pixels, and your job is to find which pixel you need, which pixel you want, right? Because your waveform can only go through one pixel at a time. And over here, we have enough resolution to see that pixel. Over here, we don't. So one way to do this is to use something called erosion. Yeah, so the thing that I'm talking about is similar to this problem of, given the image of a fingerprint, you want to get the skeleton of that fingerprint, which is like just the shape of the lines. And you can use erosion for this. The idea is that if a black pixel has neighbors that are white on one side and black on another side, they need to go away. So they turn into white pixels. And if you keep doing that from both ends, you're eventually going to find just a line in the middle. And this line, it is going to be a line because if there is a single line of black pixels, the neighbors are white. And then they don't go away when the neighbors are white. They only go away when one neighbor is white and one neighbor is black. That's when they go away. So you end up with just this line. And if you have just this line, essentially, you have a waveform. And then you can just say that those are samples, produce a wave file, and hear that. If that doesn't sound too nice, you can try some filters, I suppose. I don't know, I haven't really tried to do this, but I guess you can try some filters. Also, you probably want to watch the videos of people doing that. I think they did that on the number file channel, if I remember correctly. You can check that. Right, okay, so we are here renaming a bunch of things, and then I think we already renamed everything. We just want to review this. So to get a hold of the index, first I take it out of the data structure. I also get a hold of the size of the signal, and then I do the offset, and if it is less than 0, then I wrap back. And then I need to return this. I was so hopeful before I started the stream. I thought I was going to be able to draw the thing on the screen today. I'm going to be far from that today. If I get this data structure to work, I am happy. Right. Okay, so this looks about right. And then I want to rename this. Just like that, and I want it to be like this. Yeah, it is kind of silly to have a local variable for this. I could just do it in one line. But it's a big line. Not sure I love it. But yeah, go into the circular buffer, get the signal, get the data, and then get this. Okay, if I did everything correctly, then I can remove this, re-add, and I was gonna say go to the page, but go to the tests page, but I forgot to comment out this. Okay, second try. Oh, the circular buffer is failing. So there is a bug in my code. Let's review this because maybe there is an obvious bug somewhere. Oh yeah, signal data is not there. I'm tempted to write it like this because this assignment is already going to return the sample. But I'm going to be explicit. Okay, let's try this now. Yay, everything is passing. So this refactoring was successful. Great. Do I want to add tests for this? Yeah, I don't see why not. I mean, I am kind of testing this already because this function is used on this one, and this one is tested. Yeah, let's find where I have a dot push. And let's look at the tests. If the tests are easy to write, I will write them. And let me double check that I'm getting the thing that I expect from this index. I wonder if this get should return the address directly, this address directly, and then I could index elsewhere. No, I'm not gonna do that. I'm gonna have, if you want to use the lower level functions like this, these lower level functions, you have to dive into the circular buffer and do stuff yourself. Yeah, just to clarify, my idea was that instead of returning this value, right, when I am indexing into this position, I'm returning a value. I could instead do this, and then I'm returning the address. Or alternatively, I could do that, and then I'm returning the address. Yeah, but I don't like the way that looks. That is too magical. And you have to know, it boils down to pointer arithmetic, and I don't want to do pointer arithmetic in my library. It is confusing to do that. So Yeah, I'll just have this. Right, let's see if it's easy to add these tests. Well, it's relatively easy, yes. I have to start with this one. And where do I put the tests? Do I put them in the beginning or the end of the existing tests? I'm gonna put them at the end. Or I can follow the order, right? Yeah, let's see both of these buffers side by side, or not side by side, but up and down. You see what I mean? So before I do push, oh, all the push is in the setup for the test. This is the actual test. So yeah, trying to follow the order of the functions is not gonna fly. Let's just tack this new test at the end. In fact, I'm going to start with a get test. Do I know what this number is going to be? Let's see, I just pushed 113 and 113 is in position 2, so I expect this to be the number 2. Let's see if this test is passing. No. So what is this? It is 1? Why would that be 1? Does that make sense? Well, I guess because the rest of the tests are passing, but still. Oh, check this out. Yeah. The index into the circle buffer is 1 right now, and we don't push anything. So yeah, this index is 1. Okay. So this should be 1. And just for fun, because we are here, I'll test some negative offsets. Let's see if this test is going to pass. If this one is going to pass. Great. Then let's advance and if it was 1, I expect it to be 2 now. And then let's try again. And it should be 2 now. Okay, let's see. All right, so now all of these tests are supposed to pass. And they do. Great. So we are on our way to some polymorphic circular buffers. guess the conclusion is that things tend to be a little bit harder than I expect them to be. And isn't that the rule of everything? Right, so let's review. We broke apart the circular buffer into two auxiliary functions. And we started a sketch of what is going to be the waveform data structure, but it gets complicated. Then in the demonstration effect, we just added some tests. And what is the whole point of this abstraction in the circular buffer? Well, now we can go back to our waveform. And then instead of these slices being an array, they are a circular buffer. And to create a circular buffer, all I need is the size, am I right? Yep. And then I'm going to remove this line and this variable. And then to get a hold of the data, well, the slices are no longer an array. So I need to get from the circular buffer the signal. The signal is going to be an array. So from that, I can get the data. And you know what? I think I take it back. Let me see. Slices, no, I'm gonna keep it like that. I think that does it. Let's review. So to begin with, we have a waveform, which is a bunch of slices, which will be a circular buffer, and a duration, which is going to help us determine which samples to accumulate or how many samples to accumulate for a single slice. And I am going to assume that I was gonna say that I'm going to assume that you are going to push one sample per. You're going to push every sample into this waveform thing, but that may not always be the smartest thing. I may want to have scenarios where I don't want to push every sample into the waveform drawing. So maybe instead of having duration, I should have something like items per slice, or maybe samples per slice. And this may be a fractional number even. And I guess it could be under this name. Right. Okay. So now to create one of these waveform data structures, start by creating its data structure, then into the slices, I'm going to create a circular buffer, and then I get a hold of the data. From the signal from the array into the, man, it gets complicated. Slices are a circular buffer. Circular buffers contain signals that are arrays that contain data. Then I go into this, and this is, I suppose, it is that. So I have a local variable called that. I have a local variable called that. I need a local variable called this. And I need a local variable called that. In other words, I'm breaking the abstraction of the circular buffer. I'm diving in there and I'm putting some addresses in there. And if you want to use circular buffers in this polymorphic way, you have to sort of break that abstraction. Unless I did the pointer arithmetic thing that I was talking about. That would preserve the abstraction. Yeah, but I'm not gonna. I'll write a to-do. Consider breaking the abstraction of circular buffers by using pointer arithmetic. It gets complicated, but it preserves. Well, consider not breaking. Yeah, I think I will remember when I read that. Maybe I will remember. Right, so where are we? We have this index variable that we are looping over the number of slices, and then we are diving into the circular buffer and setting that index to be an instance of the slice data structure. And then finally we store that. And then we store the samples per slice thing. Great. Now let's quickly see how we would store a sample. I am going to get a bunch of things, maybe not all of these things, but a few of them at least. I already have the waveform, but I will have to get the slices and just mostly the I guess I need all of them. Yeah, I guess I need all of them. So remember, this is a circular buffer. Because I have a circular buffer, I can get its index. It's going to be similar to this. Yeah, the fact that at least I'm able to copy and paste this gives me a bit of hope. Right, so now I need this. I need to use that function that I extracted. I forget its name, but it's over in the circular buffer part of the code base. And I'm going to push So I need to advance this circular buffer. And what do I have in there? I have an instance of, look at this, this is beautiful. I have an instance of one of these data structures. So I guess I'm going to have a waveform slice that is equal to this. Is equal to the minimum between that and the sample that came in. Isn't that a beauty? Now, I think I want to store it as high and low, because when I'm drawing, the y coordinate is going from top down, so I think it makes more sense to think about this from top down. So I'll have high first. But naturally, I am always advancing, and I shouldn't. I should be checking this, how many samples per slice. Oh, I also need something else in this data structure. Keep finding more and more things that I need. But I need something else over here. I'll leave a bunch of to-dos. I need field to store the number of samples already collected in current slice. Over here, I need to initialize the fields explicitly, because implicitly they are going to be zeros, and that's fine, but I think it should be explicit here. Then over here I need to check only advance if necessary. Check samples per slice. So either we are going to call advance or we are going to call get. And then we are going to do this min and max trick. And when we advance, we need to reset. So when we advance, reset the high and low. And I think I need to be smart and reset the high to be positive infinity and the low to be minus infinity, something like that, or vice versa. I always get these kinds of things mixed up. But yeah, I do need to remember to reset the thing. Now I'm doing all of this management myself, but we did get some polymorphic circular buffers, which is like a crazy thing. Yeah, I'm going to commit what I have here. It's not great. It doesn't really work. I think that maybe even I have something that is not syntactically correct. Nope, the syntax is correct. So tomorrow I'm not streaming. I'm taking the day off. But on Monday I will be streaming with Aria on IDDQD Sound. I see you there. Thank you very much for watching this, and thanks for supporting me in all the ways that you do. I hope you are enjoying this. Next time we are going to continue with all of this stuff. I hope you have a great weekend. Bye.